Now we'll get started for this multiple choice exam. So the first question is the logic design. So basically for this one, we should apply the De Morgan rule. So this one is actually x greater than y bar or y less than equal to 0 bar. This one give you x less than equal to y or y greater than 0. So you actually pick number one, you actually see this one. Number two, here is a function of process, and we can see it's some function. So let's look at how it ends up with. So basically, you have a certain amount, and then you time by 100. So basically, look like it's calculating some cents, convert dollar to cents, and then plus 0.5. That's for quantization. That's actually helping to do round off. And then take modulo by 100. So actually, it's getting the cents portion in amounts, and that become an integer number. So this one, number two, should get A. Number three, what is the output for the following? You want to print sum. So you had a sum, you have this sum equals 0, D equals -1. So for this one, we actually need to trace it. So we set up a tracing, and then the count starting from 10, 9 down to 8, 7, 6, 5, 4, 3, 2, and 1. And 0, you will start. And your sum, initially your sum is actually 0. And then your D initially is -1. And you have the sum for each operation. For each operation, you actually have sum add with D. So basically, you end up doing this. You get -1, not taking the sum, -1. And then you, if it's greater than 0, you increase. If it's less than 0, actually you decrease. So actually that's increasing the absolute value. So you get the -2, and then you actually convert it to 2. And then the next one, you have this one as 1, because you're 2 plus the -1, you get 1. And then this time the D become 3, and then you convert it to -3. And then this sum together, you become -2 over here. And here you have -4 for D, and you convert to 4, and you sum together, that's actually 2. And then here you have 5, and then here you have -5, and then you sum together, that actually -3. You get -6 over here, that's 6, and then 3, and then 7, -7, and then -4, and then you have -8, and you become 8, and then there's a 4. You have actually 9, sorry, and -9 over here, and then it's -5, and then here you have -10, it become 10. Over here you have 5, and then you have 11 and -11, and here is that. So the value eventually get for the sum value will be this 5, and that is actually B. So number 3, you end up B. Okay. Number 4, recall that in Java, 0x is followed by more than some hexadecimal value. So this one is actually 15. So when you print it, it is spread 15. And then what is the output of this? You have the 16 plus 10, that will give you 26. So number 4 is simple hexadecimal to decimal conversion problem. Number 4, you have 26 plus 16 plus 10, you get 26. Number 5, the following code is actually displacing the sum from 1 to 20. And then what that's intended to do this. So what's wrong with this? It will say it won't ask you what will be the result for this loop. So it has nothing to do with this. You have to trace your own program. So basically, you have 0, 0, count less than 20. So each time your sum increase by count, but your count is not increased. So your sum every time add with a 0. So actually count is always staying less than 20. So basically this one will never get to here. So it actually in finite loop. So number 5, you have E, because it never get out of the while loop. Number 6, what is the result when the code segment is compiled and executed? So basically, you have a integer minimum value converted to integer, and then n's in value converted to double. So it's a double value for that minimum integer, and double has a wider range, so it's fine. So you will end up with this one, number 6, you will get C, and that actually give you a 14 whole number with a 14-point fractional part. So that's C. Number 7, which of the following Boolean expression implement comparison equality of two strings? 1 is definitely wrong. 2 and 3 are okay. So actually the answer, this one is a quite simple one. Number 7, you should get D. Number 8 to 9. Okay, here you have GCD algorithm. How many times will the modular division perform for GCD 12 and 15? So this one actually is a long calculation to run the GCD algorithm. So basically, So basically, you have a GCD algorithm. You get GCD of 12 and 15. And then if you have, actually you convert A, D to A. I'm sorry, A to D. So your initial value, you have A, B, and the D value of 12, 15, 12. And then you would have A modular by D, okay, and B modular by D value. And then you have D, actually each time the D will be increased if one of them is true. If none of them can divide it, you will actually achieve, it will continue to decrease D until you can no longer divide it. If one of them actually divide by D, then actually you will continue to decrease D. Otherwise, you will get out of the loop and then return D. That is your GCD. So initially, your A take modular by D is 0, B take modular by D is 3, and then you have 1 and 4, but 4 actually never been reached. So you have 1 because this one already been true, it will decrease. So here you have 2, 3, 4, that's not divided, 5, not divided, and then the next one, you have D equals 6. So here you have 11, 10, 9, 8, 7, and then the next one, you have D equals 6, and then here you have A modular by D. Here you have 0 because 12 10 modular by 6 is 0. In this case, you have to rely on second part. You have D modular by D. B is actually 15, 10 modular by 6. I'm sorry, 10 modular by 6, you actually end up with 3. So continue, you have 5, and then you have 1 over here, and it actually 10 modular, 15, 10 modular by 5, you get 0. I'm sorry. You have B modular by, let me see, B 10 modular by D actually is actually 0. So you continue. And then, I'm sorry. And then you have a 0 here, and you have 11 here. Oh, 11 is not included. And then you have 3, sorry. And then your D drop down to 3. And then your A modular by D is 0. And then you get a 0 over here. So in this case, D will 3 will be returned because both B and D, A and B will be divided by your D. So then what it wants you to do is counting the number of the modular operation as 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So totally 14 operations. So it should give you A on this problem number A. So problem number A, you get A. This one actually is quite a long calculation. Is there any good thing to estimate? If you know this is while and A is divided by something, then you just list down your number from 12 down to and find out what's the multiple of this. So basically, starting from, so the quicker way to do this, actually you have 12, 6, and then you have 4 and 3. These are the candidates to have A to be 0. And then you have 15, and then you have 3 and 5. So you have 5 and 3. That actually will divide it. Other than that, you're starting from this D equal 12. So you have 12. And on the right hand side, if there's no there, so you should have 1. And then second one, right hand side should have, because the left hand side, if there's a 1, right hand side will have 1 modular. And then your 11, 10, 9, you don't have, and then 8, 7, you don't have, and 6, you have 2, because right hand side don't have. And then you have 5 right hand side, left hand side, no. Right hand side, yes. So there are 2 on 5, and 4 left hand side, 1. Right hand side, no, and 3, you have 2. So by doing that, you actually will have quick calculation of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But still not actually saving too much of time. Now, number 9, I'm sorry. Number 9, to help test this method, the programmer decided to add one more assertion at the end before a return statement. This one actually AN9. So what would be a good assertion? So you want to make sure that D is actually the result for the GCD. So actually you should have true is that and then your D, your 3, actually you redo this GCD of AB. That's actually ridiculous. So the answer is B. You cannot do the recursive inside the GCD, so you shouldn't put the assertion with the GCD over there. You will never end. Number 10. Number 10, we have this, and then which of the following statement is true? The problem with this one is you have the 4 divided by 3, that gives you 1. That won't be accurate. So the answer is E. You actually have a smaller value that is not expected by this formula. So number 11. Number 11. Consider the following code. We read something, and then we take absolute value of it, and then we divide something, take a value. So what are the possible list of values? So each time, if it's greater than 2, you actually just convert things into absolute value. So divided by 2, and then each time you divide by 2, and then decrease by 1 for n, and repeat that forever. So this is not really hard. We basically, we would have 0. For 0, when you put 0 in there, greater than no, there's nothing like that. So you read in n, you will print out 0. 1, 1, minus 1. For 1, you put in 1. Put in 1, it actually that's greater than no. So you actually print out 1. Minus 1, it converted to 1, and then it will start there, so it's again 1. And then it doesn't go, actually it's 1. So the next one, you have 2 and minus 2. So you convert it to 2 in either case. And then 2 divided by 2 is actually 1, minus 1, so you get 0 over here. Now, this one is interesting. So you have 3 minus 3, both converted to 3. And then for 3, you actually greater than 2, and divided by 2, it becomes actually becomes 1 minus 1, you get 0 over here. And then you have 4 minus 4. For 4, you actually greater than 2. So actually the next one, you have 2, 4 divided by 2 minus 1 is 2 minus 1, you get 1. And then in that case, n is 1, you go look back. So you actually the same with 1, you end up with 1 here. So minus 1 we actually go to this. Minus 4 also go to 1. So that means that continue, that will repeat. And then 5 minus 5 and 5, you will end up with 2 minus 1 is 2, and you have the 2. So that becomes a case of 2, so you get 0. So minus 5, 5 will go back to 2. And if you continue, those numbers will just repeat the pattern. So basically, there is only 0 and 1 will show up. So the answer is C. Number 11, you have C. Number 12, what is the output for the following code segment to be executed? Okay. Now this one is testing you about the reference variable. So you have originally had A and B connected to there. So B is actually also pointing to the same location. B is also connected to the same location. And then So B connected to the same location, and C actually you have getting A0, that's A and B initially. So C actually getting the same A and B over there is a reference. Okay, so all of them pointing to the same body. So later got assigned by A symbol. So later is actually A. And then A1 got assigned by 0. And then later assigned to A1. So pretty much this is a swap algorithm. So after this swapping, A swap to B and A. Okay. And then B will see the same thing. But C actually getting the string value, it's pointing to string, not pointing to A. So A got swapped, B got swapped, but C isn't. So the answer here is BA, BA, AB. BA, BA, AB. You can see. Number 13. Suppose we have two class, person and student. The statement is the following. Compile without problem. So it passed. It passed, then which of the following must be true? First, person is constructed to have two parameter. We don't know because it's the constructor is actually from the student class. So 1, we don't know. 2, actually has student has a constructor with 2 parameter. That's yes. Your parameter is yes. 3, student has private data field of name and double GPA that we actually don't know, cannot tell. So the answer is B. Number 13 is actually B. Number 14, consider the following case. We have rectangle, and then such is the description of that. Suppose the class override the object equals method in such a way that rectangle object has the same area, themed equal. Then which of the following equal method accomplish that? You need to check for the equality for rectangle. This one is actually tricky. Okay, it says that suppose this class override the object's class equal in such a way that rectangle object with the same area are themed equal. Which of the following accomplishes this? It overrides the object. So it implies that there might be some overriding case. So the answer is E given by this. So I think you would be questioning about this one and this one. This one only allow rectangle objects, and this one you allow anything under object that actually is what? Anything under object will be able to operate to compare with rectangle. So here is that with the same area in such a way, object override objects equal. So that object, any object can be compared with that rectangle. So to be honest, this one I don't see it 100% that E is better than C, but the answer given by the book is actually giving you E, but this is arguable. I'm like 45% convinced by the author. Okay, the next one, number 15. Consider the following method. This. which describe the method performed by the method. Okay, so right here we receive a duly double array, and then over there we do swapping. Actually, it's actually swapping, yes, but you look like it's a reverse. So the answer is actually D, the reverse. So number 15, actually D for reverse. Number 16, consider the following. There's a filter and then string pattern. So you actually calculate the pattern's location in the string. And then if you don't find the pattern, then you return -1. Okay, you return the original string. That's fine. And then if you have, if you found something, you just repeat the filtering. So basically, you cut out the pattern. So you actually find the, so basically you have a string, you find a location, that's P or S for certain pattern. You cut that out, connect it into the two together. And then after you cut it out, you continue to fit the pattern in there, continue to work on the rest of the array. So basically, if you have PA, you will just cut PA out, and then eventually you should get C for number 16. Number 17. Number 17, consider the following method using binary search. It says binary search. And then which one should return -1? Okay, binary search is set up for sorted array, but this one definitely is not sorted. So not sorted, then what can we do if we fit in the C in that case? So if we got a C, which one we will not found it with -1? So we got a C, we will go this side. We look at C, we'll go this side. We look at C, we'll go, I'm sorry, this side as well. We look at C, hit, so D is out. We got a C, we will go this side. So here you do have a C, so it's possible. Here you do have a C, that's possible. Here you don't have C, so B actually is the one who creates trouble because C is not even in that side. And this one you have C on that side, you have a chance to get it. So B is completely has no chance. So number 17 is actually B. If you continue, you will still see C can be found. But okay. So what this tells us is like this actually show you if the algorithm doesn't follow the precondition, then what should you do about it? You should follow the algorithm that operates in something. And then number 18. Number 18, you got A, B, 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 C, 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 and then you kind of get the substring ABC length -1. So you actually take out a C for ABC1. And then you get ABC1, take out another. So actually you got this middle part. And then you try to get the index of ABC1 from that. So actually you got 1. This one actually got 1. Number 19. Number 19 to 20 is a set of problems. So here, whatever this is, what is the algorithm? So number 19, here, as you can see, you have a series of sorting, series of shifting. So here it has the pattern of getting the temp value, you keep shifting, and then you put the pattern in. So it's a rotational shifting. So you will get the answer will be B for the insertion sort. As for number 19, you get B insertion sort. That's not a hard algorithm to read. Number 20, given you this, and then what is the result of the 9A? Okay, you finish the whole thing after the second iteration. So you basically first time you got 16, and you shift, it becomes 16, 24. This one is 68, no shifting, so fixed over there. So you have this as A. Number 20, you get A. So you have to memorize the whole 4 different sorting algorithms by heart, knowing how to operate it. Okay, playlist provide method allow you to represent and manipulate a list of song. Is there any song? No, there's no song or copy. You are not concerned about how these operations work and how this is stored in memory. And you only know how to initiate and play a playlist and have no direct access to that. So you represent a list of songs. And then you actually, it's a list of songs, and actually you have no direct access of that something. So actually the direct access tells you, you use the master that actually is A, you have the encapsulation. Polymorphism is of different type, it not saying anything. Inheritance, we don't see extend or something. Overriding, there's no mentioning of any measure. Overloading sense, no mentioning of any measure. So next one, frequent flyer is for someone who is a club member of some airline. So we have this function, and then here we have some code. So basically, initially we have this person, Alex. The Alex is 20K. And then we have B, Bess, that give you 10K. And then we have C, that's Cindy, that give you 0. After that, actually, we each one add 1,000 miles using this pointer. This one is a reference, and that add mile is a mutator. So basically, it's become 21K, this one 10, 11K, this one 1K. Okay, let's look at what does the problem need. And then it ship out the total. Total would be 33K. So that the answer is D. So this one, number 22. 22 is D. Next one, 23. 23 has the amps utility value, and then it asks you, the constructor initialize the amp values table, row and column, fill them with random number. So it won't random number. Here it is the key, random number between 0 and 1. So you have to be a random number. And what happened is, number 1, it all 0, so it's not random number. So number 1 is gone. It's done, actually, because it's not actually a random number. It's all 0. Number 2, you get the this one, actually you traverse through the upper part of the array. So you have the array. it will go to the upper part, but when you set the upper part, you also set the lower part. So set the lower part at the same time. So actually fully covered by the random number. And then the next one is just separate row and then column. You also set everything. So 2 and 3 are correct. You actually get D. So this is actually number 23. You got D. So here, number 23, you got D. Okay, here you have number 24. Number 24, initially given size of 100. You take the samples, and then this one, samples, then whatever. Go back to, okay, this 23. Let me see, is 23, 24 are the same question. And now actually, it will need you to assign the X, the value, assign to X the value, the last row and the first column of M in S. So S is a sample. S is a sample. So sample has M's. And for M's, you want to get a certain M's data. You should get J and K. So you should have that sample S that get J and K. So you have the sample get J and K. Your last row is that's not S. That should be the size -1 and 0. So this one 24 is actually D. This get size sample need to get. So this sample get are correct. 1 is gone, E is down, and then here you don't have enter length. It cannot be reached there. This one S is not a metric. There's no enter length. So B and C are gone because of that. Number 25. Consider the following method is spread. Spread when length is less than A, you double. So you start with 2 star, and then each time you print. So you have spread of 2 star. It actually calls spread of 4 star. Then you call spread of 8 star. Spread of 8 star is passing this, so you actually will print now. So you print now 8 star first, and then you return, and then you print out 4 star, and then you print out 2 star. So the answer is E. So for this 25, the answer is E. 25, the answer is E. The next one, 26. 26, you have a list of numbers, and there's another one, a list of names. And then initially you add the number 1 into the numbers. So numbers will be 1. You actually 1, 1. So you actually 1, 1 array list. Name, you add A, B, C in there. So both in 0 location. So you actually add A and then add B and then add C in front of it. So it's a CBA structure. And then after that, what do we need? It goes through the number, remove the number from name, and number is an index. So you go through, so you actually take out of the location 1 from names, and then location 1 from name, you end up with Cindy alone. Cassie, I'm sorry. You end up with Cassie alone. So the answer for this one is Cassie. So number 26, you got Cassie. Okay, 26, you got Cassie. 27 is a random number generator. We have the 2 times master random and take integer. So on the left-hand side, you have 0 and 1, a set, 0 and 1 as a set. And these two, actually, you end up with 0, 0, 1, 0, 1. You have 0, 1, 1, 2. So your data is from 0 to 2. So this should give you 0, 1, 2, 3 possibility. And without X, so it can be E. You will get 0, 1, 2, 3 possibility. Number 28, consider the following class declaration. We have airplane, something, something, okay. As what is the result for the following code? Okay, let's get started. Airplane got assigned. Airplane, there's a plane. That's airplane, it got assigned by 4, right? And the jet, you have jet, you initial with 4, but remember there's a 2 times G over there. Be careful. So the data you put in jet actually is 8. And then after that, you print out plane that actually you have fewer of 4, and then space, and then you add floor, and you print out 5, and then you get print jet, that's actually 8, and put edit is 9, so you actually end up with, actually that is D for this question, number 28, you got D. Now it is 4, 5, 8, 9, as described over here. I'm sorry, the lower part, 4, 5, 8, 9. That's D. Number 29. 29 to 30 is a set of questions. You have cake, you have bake sale. Okay, the project has constructed the program, and then whatever. Number 29, what's the design principle at here? If make possible for the modified code to work. Modified code to work, you add the interface, and then you implement the price to cake. So cake actually is replaced by price in the bake sale. So you actually make this one not cake but bake sale but priced. So actually you make the arrays polymorphic. So actually there's a polymorphism. So the answer would have A and C left. And the next one is encapsulation and the abstraction. Now your purpose of having cake replaced by price, that's not encapsulation. That's actually abstraction. Because what? Because the interface had 2 main features. One is functionality. The other one is membership. Membership for abstract class and the interface, they both provide in membership, and also the abstract class and the interface, both especially abstract class, they already say it is abstracted. So you will have geometric object that has the rectangle and circle. Circle and the rectangle are concrete class. Geometric object is abstract. Abstract class, abstract something. Here, your cake is a solid case. And your price is something that is vague. So that is abstraction. That's not encapsulation. Encapsulation need to have private data field those hiding of information or restriction of access to be involved. So this one is actually C for number 29. Number 30, which of the following reason is a good reason to make such a change? So polymorphism, that's a good change. So K can be used with different type of force in the future for dealing with different type of priced items. So it's making it polymorphic. And then you can mix a price object. So you got 2 and 3, and items may hold a type of subclass. That's not the purpose of doing that. There's nothing to relate it to the price interface. So this one, number 30, it is actually D. Number 31, which of the result? What is the result following when the following code segment is compiled or executed? You actually get 2 to the power of 5, that is actually 2 to the power of 5. And then you do this for 1, 2, 3 times. So the first time you multiply by, so this one is multiplied, this one multiplied by 1 over it, so it becomes 11. So the first time x become this. Second time, 11 times 12, 2 to the power 11 times 12, so it's actually 23. Third time, 23, it becomes 2 to the power 47, but the integer would have overflow. It would have overflow, and when it has an overflow, which one will be the answer? E is the answer. It got zip. So you actually get E. It overflow because it's on 32-bit, and the 47-bit is somewhere here, too much. You don't get it. It's already out of the range of integer. So the answer is E. Number 32 to 35 is a set of problems. And this one actually is somewhat confusing. Okay, it's really somewhat confusing. And 32, which of the following is not valid? 32, actually you have new track, T track, let me check, track has no constructor or no archetype, no argument type. So A is wrong, so 32 is a quick pick of A is wrong. 32, you have pick A, that's a simple quick pick. There's nothing that is. 32B, I'm sorry, 33. Which of the following expression correctly refer to the duration of cache track inside the CD prayer times? Now let's go back to CD prayer time. So CD's prayer time. CD has many tracks. CD has many tracks, and then there's a duration. Get duration. Duration will access the K itself. So you should get the CD and then run the get duration. So there's nothing to do with track. So the answer is CD, and the get duration is actually a public method. So you basically just need to get this track K. So the answer is A for 33. Why you don't need to have a track? So many track over there. Let's go back. First track is private. First track is private. Second track is array list. Okay, for tracks is array list and private. So by this standard, tracks, you actually total prayer time. Total playtime, let me see. I'm sorry, here you cache track inside the player type. Cache track is actually cache track is obviously for this method. And cache track time is actually is implement over here. And right here, actually, you can access the track, but not array or array list, not array. So this one is gone. This one, this track have no get duration. So basically, this one not an array, gone. A track not have the duration gone. Duration not getting the track gone. So you have only A and C left. And the track that get K minus 1, but duration is not a function, it's a data field. So that's why we only have A stand. 34, what is the result for the following things? You have a new track, and then you actually add in the track for certain time into the tracks, right? And then for track list, you actually you put that into the CD, and CD play time, total play time. So each one is 200, and then you have 13 that actually is totally give you E 2600 will be displayed. The next one, 35. 35, the missing code, the CD's constructor. CD's constructor, you try, okay, try to add some song in there. You actually, what do you do? We shall find replace missing code for CD's constructor. CD's constructor, there's a track. We need to see whether track need to be initialized or not. That's number one. Second, you need to, from the song, try to add every song into it. Okay, let's look. CD's constructor is a missing call. We get song in, and then there's a tracks. So right here, this track has no body. There is no body. There's no already body. So we need to have that. So one is down. One is down because there's no object body for the tracks. So here is gone. Then for the song, we get every song add into there. That's actually correct. And then the next one, we get songs, the size, and then we set. This one, adding is fine, but setting is wrong because we haven't had that object I yet. You cannot set data. So the answer is 2 only. 35, you got B. You only have the 2. 3 is gone because you cannot set a data object that is not ready there. 36, a programmer write a swap to swap 2 integers, which in the following way represent the value and corresponding method successfully swap something. And first one, you swap the reference. So first one is down. Second, third, you are working on the swapping for an array elements. So 2 and 3 are correct. Number 36. Number 36, you got D. Number 37, you have a solid interface, specify something, and then get volume, and then you have the cube pyramid and implement solid, and then you add solid 1, solid 0 for cube, solid 2 by 1 by pyramid, and what is called, this is simple polymorphism. simple polymorphism to put those things into solid. What Java feature will make it possible for the following code segment to work? So number 38. Number 38, consider the following. This one looks like tricky, but it actually is simple. Say we have this something. If it is true, then if it is true, you actually jump to here, return true. If it is false, then actually it will return false. So basically this one is just return this thing. So 38 is C. It's a straightforward of the looking of the reduction of the logic expression. 39, we got this. And then there's a missing, there's another statement will cause null pointer exception, okay? And we add one, add two, and the third one, let me see, you actually create two array element, but there's no string assigned to it. So MSG message 0 is a null. So you have the 1, 2 null, 1, 2 null array of list of strings, 1, 2 null. So message 0 that's null assigned by something, that's fine. This that get size, if you get size, you get null, that's fine. So B, A, B are correct. C, if 3 that get these two compared by these two is actually not equal, so you print this, and then that's fine. This that add 2, this has 3 element add 2 with this, that's fine. There's null pointer add 2 there. Actually that's a string object, that's fine, even though the pointer is null. The last one, null does substring. Null has no substring function, so E is wrong. Now we'll create a, when you have a null pointer trying to get some method, you will create null pointer exception. So this one is E for 39. Be careful, this one's quite tricky as well. Okay, number 40. Number 40, you have a programmer trying to choose array list and a standard one-dimension array. Okay, which one is more appropriate? Okay, both array and standard array allow direct access. That's correct. Random access. A standard array may hold elements of primary data type, and array list must hold object. That's correct. C, array list of object may hold object of different types. Yes, it's actually a polymorphism. D, array list has a convenient method inserting value at a specific location in the middle. Yes. E, both array list and standard array expand. No, array cannot be expanded. So this one actually you got 40. 40, you have E as well. So let's conclude the review today. And if you have any question, let me know. I will be happy to help you. Okay, thank you. Bye now.